Hey guys, welcome to lesson 5.2.2 day 1. We are going to continue working with logs, logarithms, and just kind of practicing our skills with those. Before we do that though, I do want to review some old stuff consisting of multiplying out polynomials and then also factoring, because those topics are going to be on our upcoming test and quiz. So figured I'd go over that with you. So when you're doing the multiplication using the box method, remember that you have to set it up where one of the expressions is on one side of the box and then the other expression is on the other side. It makes sense to put them where they fit, right? If there's 3 terms, it makes sense to put them on the side of the box with the 3 spaces. The 2 terms goes on the side with 2. So once you do that, you can go ahead and multiply these out. So negative 5x times negative 3x squared, that's going to be a 15x cubed. These two, negative 5x times x is negative 5x squared. Negative 3 times negative 5x is 15x. Negative 3x squared times 4 is negative 12x squared. X times 4 is 4x. Negative 3 times 4 is negative 12. So now you do want to keep in mind that there are going to be like terms to combine, right? If we combine these two x squared terms, negative 12 plus negative 5, that gives us a negative 17x squared. And then you can also combine these guys. 4 plus 15 equals 19. So we got a 19x there. So now we can go ahead and add everything, but instead of adding all of these, we could just use these terms instead. So we end up with 15x cubed minus 17x squared plus 19x minus 12. All right, and that is our final simplified answer. All right, for this one, we are back to our box and diamond. So we start by setting it up with the first term in the top left box, third term in the bottom right box. We are now ready to do our diamond. So we get 2x squared times negative 1 equals negative 2x squared. And then 1x goes at the bottom from this middle term here. So we have to play the game. What two numbers multiply to make negative 2 and add to make positive 1? So hopefully you would realize that it's going to be 2 and a negative 1. So we'll get a 2x and a negative 1x. And that will then be what we use to fill in these boxes. So we're ready to fill out the outside now. So we've got 2 x and x. These two multiply to make 2x squared. And 2x times what equals 2x? That'll be a 1. X times what equals negative 1x? That'll be a negative 1. So we end up with I guess we could just write it here. 2x minus 1 and x plus 1. Alright, so that's it for that one. This is my final answer. Yeah, factoring never goes away, guys. It's there forever. Alright, so here's a nice little graphic to show you, how to go between log and exponential form. You really need to get comfortable with this. The nice thing is that the base of the log is always also the base in the exponential form, right? We can call it a base because it's kind of like lower. It's being raised to something else. So this base and this base are going to be the same. And it's going to be really helpful to remember that, so at least you know for sure like where one of the numbers goes. So for these problems down here, we're going to go ahead and do our little circle of life business. Alright, so we got 6 to the negative 1 equals 1 over 6. That I have just rewritten in exponential form. Same idea here, circle of life. 9 to the x power equals 395. We don't need to solve these, we're just practicing putting them in exponential form. Okay, now again, notice that this 9 that's the base in the log always is the base in the exponential equation as well. Alright, so now we're going to go ahead and write them in log form from exponential form. So just remember that if I have, and I can use this same idea. So actually I'll just use my usual. Let's say we have some log base b of a equals x. The transformation exponential form is b to the x equals a. Okay, so here, remember, 4 is the base. And so that's what we'll start with in my log, with 4 as the base. And then a, the thing in the parentheses, is going to be the thing outside here on its own, on the other side of the equal sign, so 1 over 16. And then the exponent is always going to be like the answer, if you will, like on the other side of the equal sign. Okay, and again, if you're ever unsure whether or not you did it correctly, you can always check your work by doing the circle of life and rewriting it in exponential form. All right, here we will do it again. So log base 10, remember this is always the base, and then we've got x in our parentheses because this side always comes in, and the exponent is always the answer. Okay, so again, you're just putting things in the right spot. If whatever number is here turns into this, right? Whatever number is out here turns into this. The exponent is always on the other side of the equal sign. All right, so now we've got some that we are going to solve. Let's pick a new color. Go with this. All right, so it's always helpful to rewrite these in the opposite form when you're trying to solve stuff. When in doubt, when you don't know what to do, just like switch forms and it will probably help. So here we'll rewrite this as 4 to the third equals x. See, now it's really easy because you just have to calculate 4 to the third. Now that's something you can easily do in your calculator. You'll just do 4, caret key 3, and we get an answer of 64. All right, so another one, we've got x to the second power equals 16. And then you have to ask yourself, okay, well, what to the second power equals 16? You could solve this. We know how to solve this, like if you square root both sides, and we would get an answer. Or you can always trial and error and be like, I wonder what squared equals 16. It's not 3, but 4 sure does work. So x is going to be equal to 4. Again, another way you could have done that is to take the square root of both sides and you would get an answer of 4. But all right, here, so this one's an exponential form. Now you could just trial and error your way through this. You could be like, okay, 4 to the third is too small, 4 to the fourth, too small, 4 to the fifth, too small. Like you can keep trying and you'll eventually get somewhere if it's like a nice number. The other option you have is to convert this to log form. So remember, log base, this is the base, 1, 6, 3, 8, 4, goes inside, and then x, the exponent comes out here. So now, this is actually a log that you can calculate. So I'm going to show you guys how to calculate these logs in your calculator. So if you just go to this math, I think it's on the math button. Okay, so we'll go to this log base option, right? And I'm going to show you that again. We go to the math button. I scrolled up. It's all the way at the bottom. Right here where it says log base, I pressed enter. And now I can just type this in. I can put 4 and then 1, 6, 3, 8, 4. Okay, and it's going to calculate this logarithm for me. So my answer is going to be 7. And sure enough, if I did 4 to the 7th power, I can check myself. I do get 16,384. So I know that my answer is 7. Okay, and one more. Let's go ahead and convert this to log form. So the base here is going to be 729 because that's the base in the exponential. 3 goes inside and x comes out here. So this is another job for the calculator. Let's go back to our math. Go to the log base. Type in 729. Type in 3. And let's see what we get. So this is a really ugly decimal. If you press math and press enter on this fraction function, it will change your decimals to a fraction. So you just press enter again, and your answer is then 1/6. All right, that is all for today. Try the open math problems and let me know if you need any help.